Countdown.
Tahniah! Siaran langsung ini dibawakan khas kepada anda oleh Akademi YouTuber Malaysia. Sebuah inisiatif e-didik Malaysia dan Kelab Guru Malaysia. Tumpukan perhatian anda. Siaran langsung akan bermula sebentar lagi. Link sijil akan diberikan di hujung siaran ini. Pastikan diisi dalam tempoh yang ditetapkan. Terima kasih.
Bismillahirrahmanirrahim. Assalamualaikum. Good evening and hi to all teachers, parents and the wonderful students. Welcome to Pusat Tuisyen Academy YouTuber, a joint venture with EDD Malaysia and Kelab Guru Malaysia. Hashtag bermula percuma, selamanya percuma. Before we proceed, let's begin our session with the recitation of Kitab Al-Fatihah. And for the non-Muslim, please recite your prayers according to your religion. Okay, how is everyone doing today? My prayer that everyone is in the best of health and ready to proceed with today's class. But let me introduce myself first. I am Madam Rosmaya as your moderator for today. I am from SMJKU Kajang Selangor. And together with us is Teacher Im, our host controller. Okay. She is from College Tingkatan 6, Tapa Perak. And our observer is Teacher Aileen from SMK Datuk Penggawa Timur Pasir Gudang Johor. And the most important person today is our presenter, Teacher Zainariah Abdul. She is a very experienced retired teacher from SMK Tunku Ampuan Durrah Negeri Sembilan. Yes. So let's give a warm welcome to our presenter. For the record, we are now live on Teacher Zainariah channel. So as a sign of support to Teacher Zainariah for the hard work in preparing today's lesson, please subscribe to her channel. Not forgetting also to Teacher Im and Teacher Aileen channel too. As usual, the lesson will last approximately for 1 hour. The certificate link and the credit claim link will be given at the end of this session. And remember that you can only use EDD email to claim the certificate. Okay, IU credit is for you to claim present to motivate you to study more. So the more classes you join, the more credit you can claim. So be sure to follow the class up until the end and give your full cooperation in making this session a lively one. I would also like to remind students to use appropriate language and also use appropriate profile picture. If possible, your own picture. If you wish to post comments in the chat box, I'm pretty sure all of the students here are excellent students who will uphold a positive classroom environment. And stay focused, and if you have any questions, please write on the chat box and Teacher Zana will try to provide you with the answers. So without further ado, please welcome Teacher Zana to start her presentation.
Okay. All right. Okay. Good afternoon, students. How are you? Okay. Before I begin, okay. Here is my. Can the control host share my screen now? Up. Okay. So okay, right. So this is this you can scan you can scan the QR code to get my channel, and this is my username at Zana Abdul. Later on, when you claim the credit, you must use my username, okay, at Zana Abdul. Right. I would like also to remind we have a playlist, okay, consisting of various video lesson on mathematics T. So this is the playlist, and we also have a special playlist on calculus, okay. Stpm and matriculation lesson. So this is the URL. Okay, beside this playlist, we also have a pre-U lesson collaboration with other subjects, other science subjects. Namely, we have the chemistry video lessons, We also have the biology video lesson. And not forgetting, we also have the physics video lesson. Madam Rusmaya is the head of panel for the physics panel. And also we have a special video lesson on economic and perakaunan. Okay, so feel free to browse through this URL. Okay, now our lesson for today is curve sketching. Okay, before we start, I would like to ask, how many of you sketch the graph of function by finding the coordinates of x, y, a few number of coordinate x, y, and then you plot. Okay, so this method is not wrong, okay, it's right, but it's very, very tedious. So today we'll be sharing a systematic way of graph sketching, okay? So in any curve sketching, students, please take note, all of you must understand the basic shape of the curve that must be sketched, okay? And make sure all the curve must be labeled. So when I say that all students must know the basic shape of the curve, so we have the following functions, okay? So quadratic, cubic, and quartic function form one group. So you must know the shape of these graphs. Okay, they are always continuous and they have turning points. Okay, the turning points can be maximum, minimum, or point of inflection. And then we have the rational function. In general, rational functions have asymptotes, sometimes called as the reciprocal function, sometimes known as the algebraic fraction functions. Okay, most rational functions have asymptotes. And then we have exponential function. You must know the characteristic. The exponent function is always positive. It never cuts the x-axis. And then we have the logarithmic function. It is always exists for all x greater than 0. And of course, we have the trigonometric function. So as homework, all of you go back and do some research on this basic shape, on these 5 group of functions. For trigo, only the cosine and sine is continuous, except for tangent, it has asymptotes, okay? So here are the list of the steps that we have to, that we can take into consideration. Okay, the first step is always finding the obvious point, the x and y intercept. Okay, the point where the curve cuts the coordinate axis. And then we need to find the local maximum or minimum point. Remember how to find? We know that at local maximum minimum point, dy dx is 0. And if d2y dx2 is negative, it's a local maximum point. Remember, you have to show there is a local maximum point, or you have to show there is a local minimum point. That is the condition d2y dx2 is positive, okay? So these are the 2 steps. The next step is that students must also be able to find the point of inflection, if any, yeah? If the question did not ask you to find the point of inflection, do not trouble yourself to find the point of inflection, okay? But if the question asks you to find the point of inflection, remember at point of inflection, our double derivative, that is d2y dx2 or f prime prime x is always 0. And you must prove. How to prove? Either you use f prime x or dy dx has the same sign, or you can use d2y dx2, okay, f prime prime x changes sign, or we can use the third derivative, f prime prime x is not equal to 0. Choose only one step, tak perlu buat sampai all 3, okay? Okay, next step is to determine the asymptotes of the curve. Okay, let's example. Okay, finding the asymptote for this function. This is a rational function. Okay, so this method applies only to rational or algebraic fraction function, okay, to find the asymptotes. Okay, the first method is using the idea or concept of limits. Okay, first we have the asymptote parallel to the y-axis. Okay, parallel to the y-axis, so we call it vertical asymptote, short form VA, okay? Okay, now, this is another way of writing the limits. Okay, look at the function. Notice that as x approaching 2 plus, means a slightly bigger value of 2. So your y approaches infinity. Okay, because we know that this is a fraction. When this tends to 0, okay, y tends to infinity. Similarly, as x tends to a value less than 2, slightly less than 2, our y tends to negative infinity. Why? Here, because when we minus a smaller value than 2, it becomes negative, okay? Or if you prefer to write down the limits notation, you can do this. It's the same, okay? So here y tends to infinity. Okay, here y tends to negative infinity. Okay, I would, if you ask me, I like to use the first step using the arrow. Okay, so our vertical asymptote is x equal to. Okay, but normally I will give my students a shortcut method to identify the vertical asymptote easily. We look at the denominator of the rational function. We equate it to 0. Clearly here, our x is 2. Okay, we look at the denominator, equate to 2. Okay, that is the vertical asymptote. So what about the horizontal asymptote? HA, okay, short form.
Puan Zana,
Oh,
sorry
I
to
forgot.
interrupt.
Yes, okay, I'm sorry students, I'm too engrossed in the teaching. Okay, the first code, okay, for the first digit code to claim your credit, it consists a letter and a digit, so it's A0. Please take note, get ready your pen and paper, is A0. Okay class? Right, so let's continue to find the horizontal asymptote. Okay, you can rewrite your function in this form. Okay, so notice that what happened when x tends to infinity. Okay, this becomes to 0. So y approaches 1. What happened when x tends to negative infinity? Okay, this becomes 0. So y approaches 1. The approaches 1, yeah? Make sure you use the right term. It approaches 1. So or again, you can use the symbol limit. Okay, as x tends to infinity, this tends to 0, so we have 1. Similarly, with tends to negative infinity, we have 1. So the horizontal asymptote is y equal 1. Okay, students tahu ya how to find this asymptote. Normally, to find the horizontal asymptote, y must tend to a value as x tends to infinity. Vertical asymptote, x must tend to a value as y tends to infinity. Okay. Okay, now we can use this method by rewriting this function. Okay, we find a function, we write the function in terms of y. Okay, convert to an equation in terms of y, and then we equate the coefficient of the highest power of y to 0. Okay, this is the coefficient of the highest power of y to the power of 1. So we equate to 0. So the vertical asymptote is x equal to. For the horizontal asymptote, we rewrite the function, an equation in terms of x. So you need to expand this because we need in terms of x. So y minus 1 is the coefficient of x, minus 2y is the y intercept, okay? So we equate the coefficient of the highest power of x to 0. So the asymptote, the horizontal asymptote is y equal 1, okay? So this is the second method. The third method, but this method only applies for improper fraction. We change or we write to proper fraction, okay? So from here, I always tell my students straight away, the vertical asymptote, you look here, the denominator x equals 2, and the horizontal asymptote, you look y equal 1. Okay, this is the most easiest method, okay? The easiest method to find the vertical and horizontal asymptote, but sad to say it's only meant for improper rational function. Okay. Right, so I have summarized the the fifth step. Okay, the region where the graph exists. Okay, consider here y squared equal x minus 3. We know that y squared is always greater equal 0. Thus, for this function to be defined, x minus 3 must also be greater equal 0. Hence, y is defined or y exists for all x greater equal 3. Okay, this is very simple. So there's another here example. Okay, since x squared greater equal 0, Okay, so meaning that this fraction must lie between 0 and 1. It cannot be 0 because our function does not exist. Okay, to be y to be defined, it must be from 0 to 1. It cannot be more than 1 because we have 1 over x squared plus 1 for all x. Okay, if you can't imagine it, so we can rewrite the function into a quadratic equation in terms of x. Okay, and we use the discriminant whereby for the function to exist for real values of x, we either have one root or two roots. Okay, so substitute into the discriminant, and then when we divide by negative, it becomes less than equal 0. I love to do the number line. Okay, this is the roots. Okay, the line represents the positive value. Okay, here is positive, positive times positive is positive, negative times negative is positive. So if we look at the inequality, we need the less than equal 0 means negative. So our graph exists for y between 0 and 1 inclusive for all real values of x. Okay, next step. The last step, determine the axis of symmetry if any. Okay, it's simple to detect. You look at the equation, if it has only even powers of x, must be only even powers of x, then the curve is symmetrical about the y-axis. Okay, for example here, only even powers of x. X power 4 is even, x power 2 is even. Okay, here x power 2 is even. Okay, so it's symmetrical about the y-axis. If the equation has only even powers of y, that curve is symmetrical about the x-axis. Okay, here y squared. Okay, so it's symmetrical about the x-axis. So actually there are some books give you about 7 to 8 steps, but I only took the important steps. That is the, I have summarized into 6 steps, okay? Right, point to note. Okay, students, you do not have to use all these steps in curve sketching. We only use certain steps for certain function. That's why I said earlier, you must know the basic shape of the function so that you know which are the important steps to be taken. But normally we use the first 4 steps. Okay, these first 4 steps are very important. Okay, number 5, number 6, step 5, step 6. If you have time, is for checking purposes. If you have the time, okay, you can check your graph where the graph, the region where the graph axis, and whether there's any axis of symmetry. Okay, so these are the 6 important steps in curve sketching. Okay, now let's look at the handout. Those who have got the handout. Okay, the first question is just a practice on applying all the steps mentioned. Okay, so observe the function clearly. We have y equal to x squared over 1 plus x squared. Okay, so what is the first step? We find the intersection with the axis. So when x is 0, your y is 0. So clearly when y is 0, your x is 0. So only write down once, okay? Then we see whether any axis of symmetry. We can here because of the x squared. Okay, the term in x are of only even powers. Then the curve is symmetrical about the y-axis. So we have already got 2 points here. Okay, we find the intersection and the axis of symmetry. Now, okay, region where the graph exists. So we have to rewrite the function into a quadratic equation in terms of x. So rewrite yx squared minus 2x plus y. Okay, take out y minus 2. Okay, the common factor is x squared plus y equals 0. So our A is y minus 2, B is 0, our C is y. So again, for all real values of x, okay, we use the discriminant greater equals 0. So substitute your A, your C. For AC, no squared, typo error here. B squared minus 4AC. There's a typo error here. is 4AC. I think just now pun silap kot, 4AC. So when you multiply with a negative value or divide by -4, the inequality changes direction. Do the number line again, but this time our roots are 0 and 2. Okay. Remember the convention, in always pointing to right hand side, okay? Because it's y greater than 0, y greater than 2. Again, here positive times positive is positive, negative times negative is positive, positive times negative is negative. So we need the negative part region. So the graph exists for y between 0 and 2 inclusive. Yeah? Y can be 0 or else it does not intersect the x-axis. Okay, next. Okay, I have already rewrite into a proper fraction. Clearly, you can state the asymptote for me. What is the asymptote? Can anybody guess? How many asymptotes are there? Can anybody guess? How many asymptotes? I already written the proper fraction for you.
Okay, come on, students.
Yeah.
You can write there.
Simple, it's just simple. There's only one asymptote. There's a hint here. There's only one asymptote, that is the, we have y equal 2 minus 2 over 1 plus x squared. Okay, I said to you just now, how many asymptotes are there?
Okay, got students here. Name written there L2, and then Chia Housing say one asymptote.
Okay, housing, very good. There's only one asymptote. That is y equal 2. Okay, y equal 2. Because when we look at the denominator, when we equate it to 0, we cannot equate x squared equal -1. Okay, it must be equal 0. So there's no vertical asymptote, only one asymptote. Okay, good. Housing. Right. So here we can study the behavior at the asymptote as x tends to plus minus infinity or y tends to 2. Okay. Remember here, this is x squared. When x tends to infinity, your denominator becomes bigger and bigger. So it's approaching 0. So we are left with y equal 2. Okay. Right. Next, stationary points. Okay. Tip, students, when you see x squared, there's always a stationary point. Okay, it's either minimum or maximum, we don't know, so you have to find the derivative. Okay, this is quotient 2 bad. So we differentiate your u, we have 4x minus, this is your u, 2x squared, differentiate your v, 2x over v squared. Okay, so multiply out, okay, 4x plus 4x cubed minus 4x cubed over 1 plus x squared, the whole thing squared. Okay, so you are left with 4x over 1 plus x squared, the whole thing squared. Okay, right. So we know that a stationary point dy dx must be 0, so your x is 0. Okay, to ensure whether it's local maximum or minimum, I'm using the shape of tangent method, dy dx. 0, slightly smaller value than 0. Okay, we look here. It can be a negative 0.5 or it can be -1. So we have negative on top divided by positive. So we have negative. Okay, when x is 0, dy dx is 0. Okay, a slightly bigger value of 0. So choose 1. So when we choose 1, substitute, we have positive divided by positive. So this becomes positive. Okay, so the shape is negative, 0, positive. So it's a smiley here. So 0, 0 is a local minimum point. Okay. You can use d2y dx2 up to you, but I would prefer to use this method. Saya malas nak cari d2y dx2. Okay, but if you were to use d2y dx2, no problem, go ahead. Because you are happy with it. Okay, saya tak paksa pelajar. Okay, next. Okay, gather all the points that we have. Graph exists for y between 0 and 2 inclusive. We know it's symmetrical about the y-axis. Asymptote is y equal to, and we have the minimum point 0, 0. Okay, now we are ready to sketch. So this is the y-axis. This is the x-axis. Okay, next. Okay, draw the asymptote y equal to the minimum point 0, 0. Then look at the behavior of the curve at the asymptote. Okay, remember when x tends to positive infinity, y must tends to below 2. It cannot be above. Remember, it exists between 0 and 2. Similarly, as x tends to negative infinity, y tends to a slightly lower value than 2. Okay, now we can join. Okay, so this is our sketch of the curve y equal to x squared or 1 plus x squared. Okay. But before we move on to question 2, the second code. The second code is 0, students. Sorry, just now I mentioned A0 is 2. The second digit is 2. Okay, students, the second digit is 2.
Okay, before you continue, shall we look at the advertisement first?
Yes.
So that the students can look at the question for a while, maybe screenshot.
Yes. Go ahead, do the question while we listen to the advertisement.
Okay.
Berita baik untuk semua. Kini Akademi YouTuber memperkenalkan sistem mata gancaran kredit AYU untuk dikumpul. Jom ikuti kelas tuition live AYU untuk mengumpul kredit AYU dan berpeluang menebus hadiah-hadiah yang menarik. Hadiah bernilai lebih RM10,000 disediakan secara percuma untuk pelajar seluruh Malaysia. Apa tunggu lagi? Tebus ganjaran hebat ini sekarang. Layari www.academyyoutuber.com untuk maklumat lanjut.
Okay, welcome back, students. Teacher Zana, you may proceed with your presentation now.
Okay, thank you, Madam Usmaya. Okay, so this is the second question. Okay, I hope that most of you have done this question because just now there was some request to have the question early. Okay, so first we need to show that the curve has a minimum point at x equal -5, and then we need to sketch the curve. Okay, this is a past year question for the mathematics M student, okay? Okay, again, the first part is to show that the minimum point is at x equal -5. Okay, so again we have quotient. Okay, we use quotient rule. So this is v, u is 1 minus, okay, this is u. Okay, differentiate v, 2 times 1 minus x, the power becomes 1. Differentiate inside the bracket, we have -1. So this is v squared. So we summarize, I have already summarized for you. Negative, negative, simplify. Okay, we have plus 2, 1 minus x, 2 plus x. Okay, the third one. Okay, Teacher Eileen has explained clearly the other day how to find the common factor. So the common factor is 1 minus x, 1 minus x. We take the lowest value outside. Okay, 1 minus x to the power 1. So what is left in the bracket? So we are left with 1 minus x, okay, because we have taken out 1 minus x, plus we are left with 2 times 2 plus x, because we have taken out 1 minus x. So 1 minus x divided by 1 minus x power 4, and solving inside the square bracket, we have x plus 5 over 1 minus x cubed. Okay, then find the double derivative. So this is v multiplied by 1 minus, okay, this is u x plus 5, v prime, okay, 3, 1 minus x squared times -1, 1 minus x to the power 6. Okay, simplifying. Okay, so we take out the common factor. Okay, the lowest power is 1 minus x squared. Here, 1 minus x squared. So we are left with 1 minus x, the first term, plus 3 times x plus 5. Okay, This was explained clearly by teacher Eileen. So simplifying, we have 2x plus 16 over 1 minus x to the power of 4. Okay, once you have find dy dx, d2y dx2, so now first part is to show that it has a minimum point at x equal -5. So there's so many ways, there's two ways of doing this. Either you substitute x -5 in dy dx, it must be 0, or you equate dy dx equals 0 and x must be -5. Sama je, okay? And you must substitute into your d2y dx2 to show that it has a positive value, because the question asks us to show that it has a minimum point at x equal -5. So please conclude your answer because the question say show, okay? Or you can say shown, okay? Okay, next, the question asks you to sketch the curve. Okay, remember the steps? Intersection with the axis. When x is 0, y is 2. When y is 0, x is -2. And then asymptotes, okay, students, you either use this method, rewriting it into equation in terms of y, then equate the highest coefficient of y to 0. So you have x equal 1, and then you write in terms of equation in terms of x, equate the coefficient of highest power of x to 0, you have y equals 0. But this method cikgu tak berapa suka sangat because cikgu tak nampak the behavior of the curve. I can't really see the behavior of the curve. That's why I prefer to use the limit method. Okay. So by looking at the denominator, clearly we can tell x equal 1 is the vertical asymptote. Okay, or you can do this. Okay, up to you. When x tends to a slightly smaller than 1, positive infinity, slightly bigger than 1 is still positive infinity. This is the behavior of the curve, okay, at the asymptote. For the horizontal asymptote, okay, now, take this as a fraction. This is the numerator, this is the denominator. When x tends to positive infinity, your denominator becomes very large. For a fraction, when the denominator is large, it tends to 0. Here it tends to 0 plus. Why? Because x here is positive, okay, infinity. Now, when x tends to a negative infinity, so this becomes very big, the numerator is a negative value, but at the bottom of the square, it becomes very large, hence it tends to 0, negative. Or you can rewrite, okay, remember as x tends to infinity, all this tends to 0, so 0 divided by 1, we have 0. Okay, okay, equals 0 as x tends to infinity. So y equals 0 is the horizontal asymptote. Okay, so that's why I said saya suka limit, because you can see the behavior of the curve at the asymptote. Okay, so now we have minimum point. It's easy to find the y coordinate. Just substitute x -5, we have -1/12. Okay, we have the asymptote just now. We have the intersection with the axis, 0, 2, -2, 0. Okay, now we can sketch. Okay, gather all the steps, now we can sketch. Okay, write down, label down all these. Okay, label down all these must be shown. For graph sketching, all this must be shown on the graph. So here we have -5, a minimum point. Okay, then we have the asymptote x equal 1 and the asymptote y equals 0. Now, just now we already studied the behavior. When x approaching 1 plus from the right side of 1, our y tends to infinity. When x approaching from the left of 1, y tends to positive infinity. Now we look here, y equals 0. When x tends to positive infinity, remember just now, cikgu kata it tends to 0 plus. And when x tends to minus infinity, your y tends to 0 minus, meaning that minus means below the y equal 0 line. Okay. Once we have all this behavior, and notice that it must cut the axis at 0, at -2, 0 and 0, 2. Okay, now let's join all these points and arrows. Okay, so we have the shape of the curve. Okay, so although it's a rational function, okay, because of the square, we have a turning point. Okay, in general, if there's no square, there is no turning point. But because of the square here, we have a turning point. So we have part of the rational function here, the common shape of the rational function. So as usual, don't forget to label your graph. Okay. So I hope that most of you who have done this just now got this shape. Most important thing, the shape must be correct. Doesn't matter whether yours is big or small, but the shape must be correct and labeled correctly. Okay. Okay, the third equation. This is favorite past year question. I already modified. It's a clone. Okay. 4 over x squared plus x. A rational combined with a linear function. Memang favorite. Okay. X squared. When there's an x squared, remember there's a turning point. Okay. Now first show the curve lies above the line y equal x. So in the exam, remember we have only 1 hour 30 minutes. The question will always guide here you. So the question is guiding you that this is where the curve must lie, above the line y equal x. And then find the coordinates of the turning point. So find its nature, hence sketch the curve. So this is the guide from the question. Okay, how to show that the curve always lie y equal x? For all values of x, okay, you can add real values up to you. 4 over x squared must always be positive. It cannot be negative because x squared here. Hence, when you add x, okay, it must be greater than x. So what is this? 4 over x squared plus x is actually y. So y is greater than x. Because this is a show or proving question, you must conclude. Hence, the curve y equal 4 over x squared plus x lies above the line y equal x. So in other words, we already know that it must be above the line y equal x. Okay. B, find the coordinates of the turning point. Okay, so we need to find dy dx. Simple. I choose a simple function for you. Equate it to 0. So we have x cubed equal 8. So x equal 2. So your y substitute 2. Okay, we have 3. So the turning point is 2, 3. Please answer the question. Sebab dia kata find the coordinates of the turning point. So this is the answer. Determine its nature. So we find d to y dx 2. Again, it's very simple. Okay, 24 over x power 4. Substitute x equal 2, notice that your d to y dx2 is a positive value. Again, just like to emphasize, make sure you put less than 0. So what does this mean? It means 2, 3 is a local minimum point. Okay, you can put minimum point or a local minimum point. Okay, so hence sketch the curve. Okay, so what must we find? Before we need to sketch the curve, we need to find the asymptote. Okay, by looking at the denominator, I know that vertical asymptote is x equals 0. Okay, when tends to 0 plus is positive infinity, 0 minus pun, 0 infinity. 0 plus means a slightly bigger value than 0. Choose 1. Okay, okay. So vertical asymptote x equals 0. Okay, notice that when x tends to infinity, your y tends to infinity, your x tends to minus infinity, your y tends to minus infinity. So there's no horizontal asymptote. Okay, let's check. If we were to use this method, rewriting into an equation in terms of x, we cannot equate 1 equals 0. So there's no horizontal asymptote. Okay. So next, find the x intercept. Y equals 0. 4 over x squared plus x equals 0. So your x cubed is negative 4. Okay, your x is negative 1.587. Okay. I think that's enough, sufficient for us to sketch the curve. Okay, so our curve lies above the line y equal x, minimum point 2, 3, vertical asymptote x equals 0, intersect the x-axis at negative 1.5870. Okay, we are ready to sketch. This is the point where the curve cuts the x-axis. This is the minimum point 2, 3. Okay. This is the asymptote x equals 0. And this is the line y equal x. Remember, the curve must lie above the line y equal x. And then we study the behavior just now. When x tends from the right of O, y tends to infinity. When x tends to the left of O, y tends to positive infinity. Next, we look as x tends to negative infinity. We tengok y tadi ya. Y tends to negative infinity. And x tends to positive infinity, or y tends to positive infinity. So we join. Okay, so we have a turning point 2, 3. And then remember, because there is a reciprocal function just now, so this is the shape of a reciprocal function. Okay, now there is a name y equal x, but it's no longer in the syllabus. It's called oblique asymptote. Okay, it's called an oblique asymptote because the curve will never cuts y equal x. But it's no longer in the syllabus. Okay, that's why cikgu tak nak mention just now. So don't forget, label your graph. Okay, 4 over x squared is a rational function plus x, a linear function. So this is the shape. Because of x squared, we have a turning point. Okay. So you might say, oh cikgu not fair, cikgu pilih yang tajuk senang. But this is a clone Stpm question. A clone question, okay? Okay, next
Sorry,
code.
Teacher Zana. Sorry, Teacher Zana, for the instruction. The next code,
Yeah, the next code is 9. Okay, I've given you A029. I know I need to mention, but tak apa, I'm helping you. It's A029. Okay, all right. Okay, next, number 4. I have to hurry because we have only 20 minutes left. Okay. Okay, we have this exponential function. I try to cover all, but I can only do about 6. Okay. Okay, x cubed e to the power of 3 minus 2x. So again, a combination of a cubic and exponential. Again, the question is guiding you. Find the stationary points and determine its nature. Sketch the curve. Okay. So to find the stationary point, what must you do? Find f prime x. So this is using the product rule, x cubed. Okay, you differentiate the exponential. You differentiate 3 minus 2x, we have minus 2 plus, and then you differentiate x cubed, 3x squared, e times 3 minus 2x. Equate it to, okay, saya kembangkan ya. I expand it and I simplify it. Again, take out the common factor, x squared times e to the power of 3 minus 2x. So you are left with minus 2x plus 3. Okay. So at central point, our f prime x is 0. So equate this to 0. Remember, our exponential function is always positive. It cannot be 0. So our x is 0 or x is 3 over 2. Okay, now to determine the nature, find the stationary points on the curve first. We need to find. So when x is 0, f0 is 0. When x is 3 over 2, f3 over 2 is 27 over 8. Quite easy to evaluate, right? So our stationary points are 0, 0, and 3 over 2, 27 over 8. Okay, this is the first part of the question. So now we need to determine its nature. Okay, I'm using again the shape of tangent method because cikgu malas nak differentiate the second derivative. You can apply the second derivative, it's still the same, okay? Okay, now choose a value slightly smaller than 0. So we choose -1, substitute into your f prime x. What happened? This is positive, this is always positive. -1 is this is positive. Okay, when x is 0, f prime x is 0, choose a slightly bigger than 0. Okay, choose 1, positive, positive, positive. We have positive. Okay, so what is this? So we draw the shape of the tangent. Positive, 0 is a straight line, horizontal line. Positive, okay, this is the shape of the gradient line. So what does this represent? Same sign. 0, 0 is an inflection point. So we are killing two birds with one stone. Okay, we don't have to find the double derivative equal to 0 and show it is an inflection point. Okay. Okay, next. For the point x 3/2, slightly smaller than 3/2, choose 1. Again, when choose 1, positive, positive, positive. This is 0. Choose slightly bigger than 1.5 here. We choose 2, positive, positive, and negative. So we have negative. So this is the shape of a tangent. So the stationary point 3/2, 27/8 is a local maximum point. Okay. So it's easier to use the shape of tangent method. So now we can sketch the curve, part B. So we have the maximum point. Okay, I'm summarizing for you. Inflection point. Okay, asymptote tadi, there is an asymptote. Why? Because of the exponential function. It's always greater than 0. So your y must be approaching 0. Okay, so this is the horizontal asymptote. Okay, this is the behavior of the curve. And then no vertical asymptote because this is x cubed, okay? So we are ready to sketch. You can use y, but label it as y equal f of x. You can use f of x, up to you. Okay, inflection. We look at the maximum point first. We do a graph sketch. It's a maximum point. And then 0, 0 is an inflection point. And then asymptote fx equals 0 behavior, it tends to 0 as x tends to infinity. Okay, another look at here when x tends to minus infinity. Okay, our f of x tends to minus infinity because this is x cubed. Okay, it will tends to minus infinity. So now let's join all the rough sketches here. Okay, so you have look like a cubic curve, okay, combined with the exponential curve. Okay, cubic curve combined with the exponential curve. So make sure after this we erase all this the behavior of the curve and label your graph. So we have the graph of the function x cubed times e to the power of 3 minus 2x. Okay, a combination of x cubed and exponential curve. Okay, number 5. Number 5 is quite lengthy because you need to find the point of inflection. And this is a logarithmic function. Okay, logarithmic function. So I have covered about four functions. Okay, the reciprocal, there's 2, and then we have the exponential function, we have the logarithmic function. So again, find the coordinates of the turning point, determine whether it's maximum or minimum, find the point of inflection, sketch the curve. Okay, this time you need to find the point of inflection because there's an instruction here. Okay. Again, to find the stationary point. So by now, I think you are already familiar with the method. Okay, this. Yeah, shape of tangent. Okay, right. So we use dy dx. V x squared ln x is 1 over x minus, okay, differentiate v prime to x ln x, so x to the power 4. Simplify further, so dy dx is 1 minus 2 ln x over x cubed. I love ln because it's easy to differentiate. Find the double derivative. V is x cubed. Okay, so when you differentiate u, we have minus 2 over x, yeah? Ln x is 1 over x. And then minus, okay, we differentiate v. V prime is 3x squared times u, 1 minus 2 ln x. X cubed squared is x to the power of 6. So simplifying, negative 2x squared minus 3x squared plus 6x squared here, plus, 6x squared ln x. Okay, so we simplify. You have 6 ln x minus 5 over x to the power of 4. Okay, so by now, most students are already familiar with the standard procedure, okay, in finding the stationary points. Find dy dx, find dy dx2, or find the shape of tangent method. Okay, so I've given you all these things here. So at stationary point, dy dx is 0. So equate your dy dx to 0. Clearly, ln x is half. So converting it to exponential form, x equal e to the power of half or third e. So when x is third e, your y is 1 over 2e. Now, ln x is half. Tak perlu ganti one by one here. Just say ln x here. Ln x is half. Just substitute x squared. So, to find the nature of the stationary or of the turning point, there's only one turning point, so we are safe. So substitute, okay, ln x is half. X is third e or e to the power of half. Okay, you simplify. 3 minus 5 is negative 2 over e squared, which is negative. Less than 0 must be shown. So the turning point, third e, 1 over 2e is a local maximum point. Okay. Okay, next. Okay, the question asks to find the inflection point. Okay, so you have to show, no choice. d2y dx2 is 0. So equate to 0, but it's easy. Notice that here when you equate to 0, we have ln x 5 over 6. So x is e to the power of 5 over 6. So students, you must love exponential. Okay, we have lots of exponential function values too. Okay, substitute into your y. Ln x is 5 over 6. E is 5 over 6 squared, so it becomes e to the power of 5 over 3. Okay, you have to show, okay, that's a point of inflection. So I'm using the d2y dx2 method to show that the concavity changes, okay. So choose a slightly smaller value of e to the power of 5 over 6, okay. Right. Cikgu nak lupa, what is the value of e to the power of 5 over 6? Case 2.3, so you can choose 2. Choose a value 2, substitute lah 6 ln 2 minus 5. Okay, you have negative, okay. So when x, this is 0, slightly bigger, okay, you can choose 3, so it becomes positive. So it changes concavity. So we have to deduce that this is an inflection point. Okay, so we have answer part B. You can find d3y dx3, okay, it's up to you. Because most examiners, they have alternative methods with them. So you can choose any method that you are familiar with, that you are happy with. Okay, jangan kata cikgu kata kena buat this method. No, it's up to you. Okay. Okay, now let's summarize. We know that this graph exists for all x greater than 0. Okay, it's given in the question. And it has the maximum point at third e 1 over 2e. It has an inflection point at this e 5 over 6, 5 over 6e to the power 5 over 3. And asymptotes, okay, this is ln. So what are the asymptotes? Look here. As x tends to infinity, y tends to 0. So y equals 0 is the horizontal asymptote. Okay, treat this as a fraction. When x become bigger, x squared become bigger, so your y tends to 0. Okay, and then when x tends to 0, our y tends to infinity. So this is our vertical asymptote. Most students, they can get the vertical asymptote by looking at the denominator. Okay, just finding the horizontal asymptote yang selalu problem. Okay, so but if we treat this as a fraction, the bigger the value of the denominator, your y tends to 0. Okay, now we know that the graph intersect the x-axis at 1, 0. Okay, when x is 1, ln 1 is 0, okay? So we are ready to sketch. Okay, now maximum point, tandakan, okay, shape of maximum point. And then we have inflection point, okay, changes of concavity, remember, we have the asymptote x equals 0, y, okay, sorry. So saya dah buat behavior of the curve. As x tends to 0, your y tends to negative infinity. Okay. Remember, when x becomes a smaller value, your ln is a negative value. Ln less than a value less than 1 is always a negative value. Then we have y equals 0. As x tends to infinity, y tends to 0. You see, we're killing two birds with one stone. Here we have already the behavior of the curve. Okay, cuma sini saya lupa nak tulis as x tends to 0 plus actually, y tends to negative infinity. Okay, 0 plus from the right of 0. From the left of 0 tak perlu sebab here the graph exists for all x greater than 0. Okay. So once we have already the rough sketch, let's join. Forgot the intersection. Cuts the x-axis at 1, 0. Okay, now we can sketch the curve. Smooth curve. Okay, ln, remember, this is like ln. Okay, and combined with x squared. Okay, so this is our final shape of the graph, ln x over x squared. But if you do a lot of practices, if you look at y equal ln x over x, if you look at y equal ln 2x over x, it has the same shape. If you don't believe me, you go back and sketch. It has the same shape, okay? So don't forget, students, label your graph. Y equal ln x over x squared. Okay, notice that the first 5 questions all got asymptote. Okay, the last question, I'm choosing the last simple question, trigonometry. It does come out in Stpm 2019, I think, but I already modified a little bit. I put cosine 2x. So again, find or determine the coordinates of local minimum, local maximum, sketch the curve. Okay, for sine, cosine, like I said, it has no asymptote. It's a continuous curve. It has turning point. Okay, so we differentiate our y. So sine 2x is half. Remember, the range of x is from 0 to pi. So 2x must be within 0 to pi. So your x is pi over 12, pi over 12. Okay, pi over 6 is 30 degrees. Yes, sine 30 degrees is half. Sine 150 is half. So d2y dx2 is negative 4 cosine 2x. Remember your y, what is your y just now? X plus cosine 2x. X plus cosine 2x. So derivative of x is 1. Derivative of cosine 2x is minus 2 sine 2x. So derivative, the second derivative of this is 0 minus 4 cosine 2x. So actually it's easy to differentiate. So only to find the y value because of the pi, but you have the calculator. So make sure the mode of your calculator is in radian, okay? So d2y dx2, substitute your x as pi over 12. Remember this is 2x, so 2 times pi over 12 is pi over 6. So we have a negative value. So the point here is a local maximum point. When x is 5 pi over 12, your y, substitute into your y. I forgot to write down my y here. Is y equal x plus cosine 2x here. X plus cosine 2x. So you have 5 pi over 12 minus sec 3 over 2. Then substitute into d2y dx2. Cosine 5 pi over 6 is a negative value, sec 3 over 2. So sec 3 over 2 times positive value, sec 3 over 2, negative, sorry. Cikgu nak cepat. So negative sec 3 over 2 times negative 4 becomes 2 sec 3, which is positive. So you have a local minimum point. Okay, one maximum, one minimum. Okay, now we can sketch the curve. Okay, one thing unique about trigo function, okay, you must find the value of y in the domain. So when x is 0, your y is 1. When x is pi, your y is pi plus 1. Okay, cosine 2x is now cosine 2 pi, we have 1. So it's a smooth curve, continuous. Cut the y-axis at 0, 1. And then this is a domain. There's something unique about trigo. We have to find the value within the domain. So pi plus 1. This is the maximum value. It's slightly bigger than 1. Okay, this is the minimum point. Okay, that's all. Join. Okay, it's a smooth curve. Okay, x plus cosine 2x. From x0 to pi, this must be stated clearly. So again, students, everything must be labeled clearly for curve sketching. Right, so basically, okay, I already given you the example on rational function, on exponential, logarithmic, and trigo. So you go back and do more exercises in curve sketching. Okay, and then, okay, the last code for today. Remember? Okay, is 0, students. 0. You want me to repeat all the code? Can I do that, Teacher Im? Okay, I repeat lah, yeah?
Cannot.
Okay,
You
alright,
are
right.
not supposed to. You are not supposed to.
All right, students, so the
Sorry.
last code is 0. Okay, make sure you take note. The last digit code is 0. Hopefully you have 1 letter and 4 digits, okay, as the code so that you are able to claim the credit for the and reimburse it all the attractive prizes in store. Okay, students, that's about all. I pass over to Madam Rusmaya.
Okay, with God's grace, we have reached the end of today's lesson. Congratulations to those who are able to follow our session from the beginning till the end. Before we end our session for today, can all of you please stop posting your comments for a while and click the subscribe button and activate the icon bell so that you will not miss the next class session. Then if you find that this lesson was beneficial, so click like and share to your friends on your social media. Spread the and share the goodness. Once completed, type done on the chat box before the certificate link is given as a token of thank you for your dedication in joining the free online class today. Given already, right? Okay. Okay, link for the certificate and link to claim credit already given in the chat box. Okay, so please take note the link will end half an hour after this live. Make sure to use the email, EDD email only to log in. Incorrect email used will not be entertained. If you haven't got one, please apply. The link to apply the EDD email is also given in the chat box, right? Okay. So if you wish to get more information on the online classes, go to the www.academyyoutuber.com, and to those who haven't joined EDD Junior Telegram, please do so. So once again, I would like to thank all of the students for joining today. You are awesome, feel free to share this free tuition class to your friends and teachers all over Malaysia. This is a collective effort from all the teachers throughout Malaysia for all the students throughout the country. So thank you too for being a YouTuber Academy supporter too. So I think that's all for now. See you in another session. Ingat hashtag bermula percuma, segalanya percuma. Okay, Assalamualaikum. Stay safe. Till we meet again next week. Same day, same time at Saturday, 5 p.m. Bye-bye.
Bye-bye.
Wow, banyaknya hadiah menarik menanti anda.
Wah, kini Akademi YouTuber mengambil inisiatif baru di mana memberikan hadiah-hadiah ini secara percuma. Ya, percuma kepada anda semua. Bagaimana caranya? Dengan mengikuti kelas tuition online percuma Akademi YouTuber sambil mengutip mata kredit, anda dapat menukarkannya dengan hadiah-hadiah yang menarik ini. Tunggu apa lagi? Segalanya percuma.
Jangan lepaskan peluang tau. Dah dapat banyak hadiah menarik, takkan nak lepaskan peluang.
Layari www.academyyoutuber.com sekarang untuk maklumat lanjut.
Dibawakan kepada anda oleh Akademi YouTuber.